The idea behind linear programming is to take a real life situation in which you have limits as to what you're able to accomplish, and within those limits, maximize or minimize a goal. For instance, in this problem we're going to do first, we're going to try to maximize our profit. Okay, and so I'll read this just in case it's not very clear. A bakery bakes 2 breads, type A and B. One batch of A uses 5 pounds of oats and 3 pounds of flour. One batch of B uses 2 pounds of oats and 3 pounds of flour. The bakery has 180 pounds of oats and 135 pounds of flour. One batch of A yields $40 in profit. One batch of B yields $30 in profit. How many batches of each type should they make? So what I'm going to do is, just like we've been doing with our word problems, the first thing I always do is I try to figure out what my variables are going to be. And just like before, for that, I'm going to look for the question. And that should tell you what you're looking for. And they say how many batches of each type should they make. So we have type A and type B. And so I'll define my variables. And I think it would be very clear if I say A represents number of batches of type A. And then B is number of batches of type B. And so we have our variables, and now, just like before, we can find an equation and we can find inequalities related to these variables. And so I'll go ahead and read the question again, and I'm going to look for my inequalities. And before I even read the question again, I'm going to realize that there are some hidden, what we'll call hidden constraints here. There's no way that the bakery could make a negative number of type A. And so I'm going to start by saying I know that A has to be greater than or equal to 0. So we have our first constraint, the first thing that limits us. There's no way to make a negative number of type A's. And likewise, another hidden constraint not mentioned in the problem is that we aren't going to make a negative number of type B's. Okay, but then I'm going to go back up to the question, and now I'll find the constraints that are given to us. And we'll try to figure out how we can use this information to formulate our inequalities. And this is just what we've been doing with equations and inequalities up until now. And so I'm going to read this part right here. I know I'm going to look for my limits. I'm limited because I only have 180 pounds of oats. And I'm going to make a verbal equation by reading what I have. I know that type A uses 5 pounds of oats. So for every batch of A, I'm using 5 pounds of those oats that I have. And likewise, type B uses 2 pounds of oats. And so this should seem familiar to us now. I think we can write our third constraint, and I'll say it verbally as I write it. The pounds of oats for type A, which is 5 pounds times however many batches we make, plus the pounds of oats from type B, which is 2 times the number of batches we make because we use 2 pounds per batch. This can't exceed the limiting factor that we only have 180 pounds. And so the sum has to be less than or equal to the 180 pounds of oats that we have. And so take a moment, pause the video, and you try to come up with the fourth constraint. Okay, so I'll find the fourth constraint, and I'm going to find it by asking myself, what else limits me? And I'm limited by how much flour I have. Okay, so I have 135 pounds, and for the type A's, I'm going to use 3 pounds of flour for every batch, And same with the type B's, 3 pounds of flour. Okay, and so my fourth constraint would be the pounds, oh, this is giving me trouble here. The pounds of flour from type A would be 3 times the number of batches, because I use 3 pounds per batch, plus the pounds of flour from my type B's, which is again 3 pounds per batch, has to be less than or equal to the total number of pounds of flour that I have, which was 135. Okay, so we call this our system of constraints. And this should look just like what we did in class the other day. Okay, I have a system of inequalities. The next step then, and the reason I have this with graph paper in the background, is we want to graph this system. Okay, so I'm not sure if I have enough room on this page. I'll go to my next page. Okay, so I'm going to have 2 axes. I'm going to have an A-axis and a B-axis. And we look at our system, our first 2 inequalities are going to be very simple. Okay, I just really need the first quadrant of this coordinate plane. And so let me start drawing this. So I'm going to call this my A-axis and this my B-axis. And so since I know that A has to be greater than or equal to 0, okay, what that means to me is that I'm going to be shading where all the A's are positive. So I drew that little arrow up there. So to the right would be where all the A's are positive. For instance, this might just, if you count 5 to the right, that would be 5 batches. Okay, and then my second inequality was B has to be greater than or equal to 0. And so I'm going to remind myself, when I shade my system, I have to shade above that axis, and this is where all the B's are positive. Okay, but now I want to go back and look at my next 2 inequalities. And they're in standard form. And so what I'm going to do is what we've been doing. I'm going to try to find their intercepts. And so I'll find the intercepts for my first one. And just like we've been doing, it's supposed to look like an arrow, I'm just going to cover up the different terms, because for my B-intercept, for this first one I'm about to do, okay, I can find the B-intercept because that it will be on the B-axis where the A is equal to 0. And so that first term, 5 times A, since A would be 0, would just be 0. So I get this, think of it as an equation, 2B equals 180. And when I solve that, I find that my B-intercept is when A is 0, B is 90. So there's my ordered pair. Okay, and then for the A-intercept there, that would be when B is 0, so I would just cover that second term, and I have to divide 180 by 5, and so I have my A-intercept. Okay, and then we'll do the same thing for the next inequality. I'll find my 2 intercepts there as well. Okay, so, and they're going to be the same. Just cover one of the terms up. For instance, if I want the B-intercept first, when A is 0, I need to divide 135 by 3. And so I get my B-intercept, which would be the same thing. Whoops. The same thing for the A-intercept. Okay, so now I'll go down and I'll plot those points. I should make them sizable so we can see them clearly. And I'll try to color code my different lines. I'll make one blue and one red. I'll make the first one, I'll put a little dot by it. I'll make the first one of these blue. And before I do it, I could choose to use a dashed line on here, but I have the or equal to part, so I'll be using a solid line. Okay, so let's scroll down and let's figure out how big we should make our increments before I even plot these. So my biggest intercept goes up to 90. Okay, and so let's see what we have. If I make each increment 10, and I should definitely mark that on here, each increment 10, both ways, hopefully this will be sufficient. I'm not supposed to say 10, that's awful. Okay, so there I've marked my increments. And remember, A is number of batches of A and B is number of batches of B. Okay, so let me look back. I want to plot a B for the blue line, for the blue inequality. I want to plot 0, 90. And so it'll just be 9 up right there. And then I'll look back. Its other intercept is 36, 0. So note, this is going to be a bit of a challenge. So 36 would be about right there. And I want to now connect those intercepts. And so there I have the line, but just as always with inequalities, I need to shade. And so I'm going to look. Okay, I want to test the origin. I want to see if the origin makes this inequality true, this first one, the blue one. And so if I replace the A and the B with 0, I'm testing to see if 0, 0 makes it true. And since 0 is less than or equal to 180, that means that the origin is part of the shaded region. So to remind myself where to shade, I'm going to give myself one of those little arrows to remind myself that for the blue one, I'll be shading toward the origin. And forgive me for how sloppy this is. Okay, so next we want to do the same for the second inequality. I'll make this red. Put a little scribbly dot by that. So I'm going to plot my intercepts for the red one. They're both 0, 45. Okay, so let's scroll down. 0, 45 is approximately right there, and then right here. And as before, I want to connect these. And now I have to choose where to shade again, so I'll go back up and I'll test the origin by replacing the A and B with 0. And I get 0 is less than or equal to 135 again. And so I'll give myself that reminder that I always give myself, that I'll be shading toward the origin on this one. All right, so we graphed all of the inequalities, but what we now have to do is we have to shade. Okay, we have to shade the region described just like we did the other day by all of these arrows. And so I'll try to make this really clear if I can. I have to shade the region beneath both of the diagonal lines, but also, if you look, above the A-axis and to the right of the B-axis. And I hope it's really clear. I'm going to just do my best here, that the region I'm shading is right there. And we call this the feasible region. And what that means is, given our limits as to how much flour and how much oats we have, I could choose to make any number of batches within that region. For instance, I can make 10 batches of A and 20 batches of B, because that ordered pair would be, let me try to plot it for you, would be within our feasible region right there. Or conversely, I can make, it looks like I can make 20 batches of A and 10 batches of B. But what we're now going to do is choose the best point in that region that will maximize our profits. Okay, so there's something called the vertex principle. And what it states is that the maximum and minimum value for our objective, in this case the profit, the maximum profit, will occur at a vertex of the feasible region. So at a corner of a feasible region. And if I zoom in, okay, maybe I could highlight the 4 corners that I see. And let me choose a color that will stand out. Let me try dark purple here. So one corner of the feasible region, clearly right there. Another corner, clearly right there. A third clear corner is right here. The difficult vertex is where those two diagonal lines intersect. So what I now need to do is I need to make a list of all four of these vertices. And so I'm going to make that list, and I'll just put it on this graph right now. Okay, one vertex, the bottom left vertex, the origin is 0, 0. Okay, this top left vertex, well, you remember that was one of the intercepts for the red line, and they were both 0, 45, and 45, 0. So when I scroll back down, okay, that top left one, the vertex there, must be the ordered pair 0, 45. Okay, but then the bottom right vertex, okay, was the x-intercept, or I'm sorry, the a-intercept for the blue inequality, which was 36, 0. So I'll scroll back down and I'll list that now. 36, 0. But it's this vertex right here that for us will be tricky to find. Now, on your test, this will not be so difficult to find because I'll give you a nice graph to work with, and you might be able to solve this system just by looking at the graph. Because remember, the solution to a system of equations where two lines intersect is the ordered pair, where they hit each other. But since my graph is so hard to read, I'm going to go ahead and solve that system differently. So I'm going to look back up, back up top here. And what I'm looking for is I'm looking to see where these two inequalities, here and here, hit each other. And we've learned how to solve a system like this. We can choose to solve either by elimination or substitution. And I think when we do linear programming problems, for the most part, elimination will be the one that we want to use. And so I'll give you a moment to think which variable you would try to eliminate. And so I think it would be easiest, because 2 and 3 are smaller than 5 and 3, I'm going to try to eliminate the b. And I'll just do my work right here. Okay, so I'm going to multiply this top equation by 3. And so I'll be distributing 3 to all the terms on both sides. I'm multiplying both sides by the same thing. Since I want, and that will give me a 6b. When I do that, I need to have a negative 6b on the next one. So I'm going to multiply the bottom equation by negative 2. Okay, so I'll go ahead and distribute. I get 15. Oh my gosh. 15a plus 6b. And now I'm treating these as lines, and so I'm not going to write less than or equal to, I'm going to write equals. And then 3 times 180 is 540. So then I'll distribute a negative 2 to the bottom inequality, but I'm going to treat it like an equation again. And I get negative 6a minus 6b is equal to negative 270. And I have the opposites in the b column, so I can now add my columns like we've learned. So I get 9a, the b's eliminated, I'm not going to write 0 there, equals 270. And when I solve, I'll just divide by 9, and I get a equals 30. Okay, so now I'm going to scroll down, and I'm going to check, there's a lot of work, maybe I messed up, and I'll look at my graph. Does it look like the a coordinate of that point is 30? And it's right on there, right on the 30 increment. And so I think our work must have been correct up there. So I have 30 comma something. And so now I need to find the B coordinate of that point, and we know how to do that. I'm going to replace A in what I think is the easier of the two inequalities, the original ones, and solve for B. And so I'm not sure which you think is easier. I don't know, I'm going to take the top one. I'm going to replace the A, and I'll show my work, with 30. So I have 5 times 30 plus 2B. And once again, I'm going to treat this like an equation. Equals 180. I'll multiply. Subtract. And divide. And oh my gosh, I obviously made a ridiculous mistake. I'm going to leave this up to make a point of this. So B equals 90. I hope that you saw that as I was talking, I forgot to subtract the 150. But you would know that by looking at your graph. There's no way that that ordered pair right here has a B coordinate of 90. And so I really hope you would have noticed that mistake and gone back and fixed it. So I'll go ahead and I'll see if I can fix what just happened there. Let me get rid of the graph paper. There, it came back. Okay, so I said I was going to subtract the 150. I just didn't do it. So I have 2B equals 30 and divide by 2. And I get B equals 15. Now let's go back down and see if that's a more reasonable approximation. Actually, it's not an approximation. Our graph is poor. And it looks like it's a tiny little bit higher than 15, but that's just because my artistic skills are lacking. So I have my 4 vertices. Once again, I'm going to repeat what linear programming does for us now. Okay, so we're trying to maximize our profit. And with linear programming, what we now know is that one of these ordered pairs will give me the highest possible profit for the constraints that we have. And so maybe I should make 0 A's and 0 B's. Maybe I should make 0 A's and 45 B's. Okay, what we now need to do is figure out which will maximize our profit. Okay, so now what I'm going to do is go back to the original problem and figure out what my profit is. Okay, so they tell us right here how to determine our profit. Let me try to make this as clear as I can. So this is where I'm looking. For every batch of type A, I get $40 in profit. And for every batch of type B, I get $30 in profit. Okay, this will give us what we call the objective function, our goal. Okay, and so we need to write this down somewhere. I'm going to go to the second page, but I'll give it to you verbally right now. Our profit P will equal the profit we get from batches of A plus the profit we get from batches of B. And so now I'm going to go down and write an objective function. I think this is a good place to do it right here. So my objective function, my profit equals $40 for every batch A plus $30 for every batch B. Okay, so now what I'm going to do, realize I'm writing these vertices in alphabetical order like we've talked about. I'm going to replace for each vertex the A and the B. Now this clearly will not be giving me the maximum profit, not doing any work whatsoever. I'll add those up and I get 0. Okay, here going to once again test this vertex. And so what do we get? 135. I'm sorry, 1,350. That's a 5. Okay, for this vertex, oh, this is math now. I should have brought a calculator. 40 times 36. That's a 6. Plus 30 times 0. Let's see, 40 times 36. That'd be 360, 720, so 1440, I believe. And then finally, our last one. So before I do this one, okay, we can see my profit would be 0 if I made 0 batches of A and 0 B. 1,350 if I made no A's but 45 batches of B, and so forth. And so I'm going to test this last one. Oh, let's see if we can do this math. So I believe that's going to be 1,200. I'll do this math right below here. 1,200 there, and 450 here, so 1,650. Okay, so we've finished all the math, but now we need to actually answer the question. Which of these vertices in this feasible region, which was graphed from our system of constraints, would maximize our objective function, and our objective was the highest profit? So we're going to read the question one last time. How many batches of each type should they make? We're going to answer with a sentence. And so I'll say they should make 30 batches, that's a 30, of type A, and 15 batches of type B, for a maximum profit of, and I have to look back up, what was that? $1,650. All right, so I assume that seemed like a lot. I'm going to make one more video, and instead of teaching you what we're doing, I'll just show you how actually the process isn't all that bad. And I'll try to be very organized in the next video. Okay, good luck.